Hello YouTube! Today I'm going to show you how to make some shaders in Shadergraph for Unity. I'm going to show you a crosshatch shader, a broken line shader, and a halftone shader. The first shader we're going to take a look at is the halftone shader. The shader that looks like a newspaper or a magazine with shading done with dots. To get this effect, the first thing that we need is actually, believe it or not, dots. The thing is that what Unity and Shadergraph has for us regarding dots, it's the figure procedure shape ellipse. And it is not very easy to tile, and after you have tiled it, if you go 1 and 1 or even greater, you end up with squares, you end up with a chessboard pattern instead of with, well, dots. I'm sure there's works around that, and there's probably other ways to get the dots, but we are going to do the following. We're going to start with a sine wave. We have previously tiled the sine wave, and we have also rotated it like 45 degrees more or less. And since the sine wave goes from -1 to 1, we want it to go from 0 to 1, we remap it. And then we take the polar coordinates. The polar coordinates give us these nice circles which have very soft borders, and that allows us to cut off or remap at different values to get smaller or bigger circles, or circles that are completely fused together into black, which is what we want for the effect. To get there, we also need the lighting of the scene. So to get the lighting, and I did this in most of the shaders, we need to start getting the main light, and this is a tricky node. This is a node that doesn't work in all versions of Shadergraph with all render pipelines, so you're probably going to need to experiment with that and see what works and what doesn't. In this version, the main light needs the world position of the object, and using the light direction at that position and the normal vector of the object, we get how much light is that object taking at each particular point. Since this again goes from -1 to 1, we want to remap it. For these kinds of remapping, I usually do this. I create a property that is like an offset that determines the point where it starts and ends, like so. And then I create a range to see how sharp is the border between light and dark. And well, if you do this, you subtract the offset and then add the offset and use that as an input for the remap, you get this really nice gradient from black to white, which represents how light the object is on each point. To get the points to distribute through the screen and not through the UVs of the object and the texture mapping of the object, that we can do too, but depending on the density, on the texel density in each part of the model, some models have more density. For example, models of human beings usually have more density in the face that, I don't know, in the back. It usually looks much better to have the points distributed in the screen, And to do that, we're going to do the following. We get the density. And why don't we use the density directly? Well, if we use the same density through the screen goes from 0 to 1, one side being 0 and the other side being 1, and the same bottom up. And a problem with that is not proportional to the aspect ratio. So if the screen is much wider than its taller, for example, then we're going to get stretch circles. So we're going to need to get the aspect ratio, getting the width and the height of the screen and dividing them and multiplying it. And now to combine the lightning and the dots, we remap the dots in such a way that the cutoff for the darker parts is much higher, and for the lighter parts it's much smaller. So well, we get the dot effect that we want. And finally, I have this other base shader, which is just cell shading to kind of like enhance the effect so it looks a bit like Paintathon. And well, I just multiply that. You can also multiply the colors at different points and use other types of blendings. This is a basic version, but there you have it, a halftone shader. The next shader is the broken line effect. For this, we're going to need three things. It has three main parts. The first one is the lines. This is similar to how we got the points in the previous shader, but it's actually simpler and easier. We just use a triangle wave, do the same remapping to go from -1 to 1 to 0 to 1. It's basically the same as the sine wave. We saturate, we do the step before that. We need to do the tilling using the line density, and I like to also rotate it a bit, rotate the lines a bit. It can also be done using a material property, so it can be changed from the material. Haven't done that. And after all these steps, and the line width in a step function, we end up with the lines, which is the first part. The next part of the shader is the lighting, which is basically the same I have used before. Is the main light, the position, using the position and doing the dot product with the normal. We get the lining on each part of the object and we remap it to get the blending that we want. We saturate it and we end up with the linings. And finally, the third part is the noise. I am using the noise times the lining to break the lines and make them look like dashes. I am using the same screen position that I have used here to create a grading noise. The scale of the noise comes from outside, and adding this to the lining and then stepping it, we get a gradient where in the darker parts of the geometry we get more solid, and adding that to the step we get the broken lines on the border. Then we get the shadow to keep the shadows hard. We isolate the shadows and we multiply them in now, and we saturate again, and adding this to the base shader, to the cell shading, we get the broken line effect that we wanted. Finally, the crosshatch shader is the most complex of the three. There's still plenty that could be added, like noise on the border, but it is complex enough as it is, and we're going to start with the broken lines effect. We can start this effect with lanes again, with a triangle wave and some tiling and offset, using a parameter, the line density, to tile this. We will see the noise soon, but the way we get these broken lines is basically using a Vornoi effect, and this was not very easy. I'm going to tell you why, and I'm going to tell you a bit about Vornoi. So the point of the Vornoi effect is to divide the space in a grid, and within each cell of that grid choose a random point within each cell, and then different effects can be achieved using those points within the grid. So the first use of these Vornoi points is to calculate for each point on the screen what's the distance from that point to the closest Vornoi point, and assign a value depending on that to that pixel, and that's what we got here. That's how we get all these points. The dark points are the Vornoi points, and as the pixels get away, they get brighter. The next thing that we can do is to assign to each pixel on the screen a random value depending on which one of these points is closest to that pixels, and that's the way we get this stained glass effect. And the third thing we can do with the Vornoi points, the third most common use, is to calculate the distance each pixel has from the walls, from the divisions between the cells. And what I needed to use for this effect was the stained glass effect and the walls, but there is a problem, because if you look at the standard Vornoi node in Shadergraph, you get the points and you get the stained glass, but you don't get the walls, and it is not trivial to get the walls from any of those two inputs. Thankfully, the Vornoi noise formula is no secret. There are several implementations around, and I found one. I found this one. I will share the link in the description to the page where I found it, but it had a problem. This one only had the walls and the points. It didn't have the stained glass, so I had to add the stained glass. Fortunately, the stained glass is like the easiest to implement out of the three outputs that we can get of the Vornoi points. And basically what you have to do is, if you use the code from the page that I will link, you need to add another output, which is going to be a float, and this line of code. There are other ways to implement this. I'm just taking the x coordinate of the point and doing the module, and that's it. There are more random ways to do it, but this works quite well. And with that, you can get the three outputs from the same node, which they will also match. You can see that they are defined in the same borders, etc, etc, which is something that we need for the effect. Okay, now that you know how the Vornoi effect works, we can use it to get this broken effect. We basically get the stained glass effect and we pass it to a rotating node, and this gives different rotations to each one of the cells, and applying that we get the broken triangle wave. And using smooth tape and power, we get the lines we want. The next thing that we want is to get some space in the divisions, and that's why we did need the wall of the wall effect of the Vornoi noise. Using the same thickness and the smoothness that we use with the shading, for example, we get the lines the way we want them, we multiply it by the lines, and this gets us, this gets us the lines that we wanted. Crosshatch, and we can output them and use them in the shader. And of course we also have this noise effect going on here that allows us to blend the lines. We can add some more density and add some more distortion, and we're going to see those lines starting to come and move a little bit, or a lot. We can also change the scale of the effect. So one of the parameters it defines how much the effect affects the lines, and the other one how wavy the lines are. And now within the Crosshatch shader itself, we only need to apply the light. We do the dot product. This is also the same that I've done in the other shaders, of creating a cutoff and sharpness values for remapping the shades, the lightning. And then I apply the lighting as the line thickness in 3 different instances of the broken lines effect. I multiply them all together, and I just add the base shader at the end, and that's all. That's how you get these effects. Hope you like it, and see you around.